an incentive structure. Free drinks for listening to us yap about chain abstraction. This should be fun. Anyway, thank you all for coming. My name is Adjei. I'm one of the co-founders of Orb Labs, and I'll be speaking about a chain abstracted feature for every wallet now. If you have any questions, I guess I want to be as interactive as possible, so just feel free to sort of raise your hand and ask. And yeah, please enjoy the next 10 to 20 minutes. So when guys were signing up for this event, we actually made me fill out a questionnaire. About 1,000 people filled out this questionnaire. Well, half of 1,000, around 500 people filled out this questionnaire. And the question we were asking was, what's the biggest UX problem you see in the Web3 space? 3 problems came out, at least the 3 big ones. The first one was account and liquidity fragmentation in multi-chain transactions. The second one was the wallet experience being complicated, the number of transactions you need to sign, the number of requests you need to fill out, and things of that nature. The third was basically onboarding complexity, how difficult it is to onboard users from Web2. The last one was sort of like a hodgepodge mix of security, privacy, and a bunch of other things. Among the sort of 1,000 people, 100 responses we got, I think the 4 most interesting comments were the ones we outlined there. The first one said, we have hundreds of chains, and we need a bunch of different gas tokens for each chain, which sucks. The second one was having to keep track of your assets and moving them from chain to chain to interact with applications. It's pretty tedious. The third one was more so around, again, something very similar, which is a bunch of fragmentation and not that much connection between the applications and the protocols on different chains. And the last one was something that we're all familiar with, which is bridging, why bridging sucks. And all 4 of these problems tie back to this sort of like giant problem of chain abstraction and why chain abstraction is the missing UX for crypto. So this may come as a surprise to people who want crypto later on, but if you were in crypto around 2016, it would be fair to acknowledge that crypto was actually a lot simpler in 2016. In 2016, for crypto, to use crypto, all you need to do was get at least on-chain crypto, because for the most part, the only chain you cared about back then was Ethereum. Ethereum had smart contracts. Bitcoin and Co were fine, but you couldn't really use them other than just transferring tokens, so no one really cared about them, you can't turn using them. All you needed was get your MetaMask, get some random private key, store that string in some notebook, and keep moving, and just interact with any application you want on chain, and you were fine. But things changed, because we started realizing there are these problems with very many to solve, the big ones being block space, and the cost of block space, and that led to the alt-1 revolution. The idea for alt-1s were, hey, we're going to reduce block space by virtue of creating new chains that had cheaper systems in place for sort of sending out transactions. And by doing so, we just made crypto as a space better. And we achieved one of those objectives, which was this abundance of block space, because these new chains did give us more block space. The problem, however, is they also came with a bunch of other problems. The biggest one being fragmentation. Now, as a user, you didn't only need to sort of like have your seed phrase or your MetaMask. You sometimes need a new wallet, you need to understand new gas tokens, new systems in place, new virtual machines to sort of interact with these chains. And after the whole L1 sort of like wave took its course, we basically went back and we said, okay, how do we solve some of these problems? The biggest ones being the new wallets and new gas tokens by bringing some of these systems back into Ethereum. And that led to the second wave of blockchains, which were the rollups and L2s. The idea there was with the rollups and L2s, you would have all these solutions of this explosion of block space. But you wouldn't have the problems that came with adopting new virtual machines and new wallets, because everything would happen in an EVM. And yeah, we got these L2s all right, but that came with a problem of what? More fragmentation in your account level. It was no longer the case that the account you had on, say, Ethereum was the same account you had on Arbitrum. It wasn't the case that the account you had on Arbitrum was the same account you had on Optimism. Every chain had its own account, and now as a user, you were forced with knowing what was going on across all the different chains where you have accounts in order to interact with crypto smoothly. And about 2-3 years ago, Bo can attest to this, we tried solving this sort of fragmentation problem with the interop protocols. There's a whole wave of companies that came with messaging protocols in an attempt to sort of like solve this fragmentation that came from these L2s. And they did work in connecting these blockchains and making it easy for us to pass data across these chains. But passing data wasn't enough to solve this problem that was generated with all these block space, because even if you have all these roads for getting to places, users just aren't willing to figure out every single road to get everywhere you want to go to. We're not going to become crypto GPSs and figure out how to sort of navigate and migrate assets across 1,000 different accounts and sort of use the application we want to use. But especially not in a world where there are alternatives to these transactions. We can basically find some sort of centralized exchange that allows us to do what we want to do. Or you can find some sort of like Web2 product that doesn't even rely on crypto that gets us where we want to get to. And so we're stuck with this world where, well, us as users are grinding through all this hodgepodge mess of protocols, tools, and infrastructure to just try to figure out how we can use this, well, new data structure we've created, which is blockchain, more efficiently. Chain abstraction fundamentally is this idea to change and get rid of this problem. The main idea here is, instead of having users know everything to get everywhere, how about we made that system automatic? How can we make the system do something that just happens in the background without users knowing it's happening? The internet runs fundamentally this idea of abstracting away most complexities with interacting with the network itself. It's the reason why most of us today have no clue how most HTTPS and all these protocols underneath the internet work. It's because someone else is sort of like taking effort and figuring out all these complexities. And chain abstraction is no different. We're trying to do that now for blockchains. Now, with the chain abstraction, you're running into two problems that need to be solved. The first one is a data problem, and the second one is an account problem. All these problems again tie back down to this fragmentation issue that we've created. Now, the data fragmentation problem is a problem that we don't hear enough people talk about. Most people tend to talk about the account level problem when it comes to chain abstraction, but not the data problem. So we tend to not notice how much of the crypto experience is entirely dependent on us just having access to good data. Remember, blockchains are data structures for the most part. And if you look at any application interacting with it, be it Uniswap, an NFT sort of like marketplace, even if you're transferring tokens to your friends, in most cases, the applications are asking your account or you, the user, some information about the account you're using. They're asking you how much assets you have, what balance you have, in an attempt to figure out what transactions you can actually execute without you sending down faulty transactions that will ultimately fail and cost you money. And in the world of chain abstraction, in the world of this much fragmentation, we have a problem because there's actually no central place where application developers or wallets can get this sort of like easy, unifiable data about user accounts. Because the user accounts no longer exist on one chain, they exist on dozens of chains, on hundreds of them. And so now you need some sort of tool that sort of figures out most of this data stuff, unifies all this account information, provides that to applications and laws in a manner that's usable. And that's the first problem, the data fragmentation problem. The second problem is the account fragmentation problem, which is, as I mentioned earlier, with the amount of fragmentation that came from the alt L1s and L2s, we no longer have accounts being this one single entity that exists on one chain anymore. Your account is actually a cluster of accounts. Each chain having its own account that you need to sort of figure out how to sort of like use when you interact with applications. And in a world where you have all these accounts that are fragmented, you need a way to find out how you can move state and transition all these different accounts and assets into different places in different accounts in order for your everyday transactions to work. And that's the account fragmentation problem. Both of these problems need to be solved to enable chain abstraction. You can't sort of like solve chain abstraction by only solving one. So in light of these two problems, it's actually better to think about chain abstraction as a orchestration and coordination problem. The coordination being related to how you sort of coordinate all the account states, and the orchestration part related to how you orchestrate these changes in account states across chains for your transactions to work. And so to solve this problem, there are actually three things you need to do. The first one is in relation to the data fragmentation problem, which is you have to be able to unify account states. So you need to find a system that sort of like creates this holistic picture of the user account. So anytime anyone comes to you asking you about the user account, you can basically give them very vital information about everything the user is asking for. If some application comes and asks us, okay, how much USDC do you have? And that application sits on, say, Ethereum. You have to be able to tell the person all the USDC that user has, even if that USDC is blocked on, say, Solana, or the Cosmos ecosystem on Noble. It doesn't matter. USDC everywhere needs to be reported. This system needs to do a good job keeping track of all the states and providing that to applications. So that's the first step, unifying the account state and being able to make it queryable to applications and wallets. The second step is figuring out what state transitions need to happen on the accounts for transactions to succeed. So if you have a bunch of different accounts, it's very possible that you're interacting with an application, you've told the application how much USDC or how much of any asset you have. The application thinks that, hey, you're now capable of executing this transaction because you have the prerequisite amounts of state or assets or whatever. But the problem is, the account that's interacting with this application doesn't. It's the whole cluster that has that state. So you need to figure out a way to sort of like look at this cluster of accounts and determine what state transitions need to happen across all these clusters of accounts for this arbitrary transaction you're sending down to succeed. And that's step 2. The third thing you have to do is you have to be able to orchestrate these state transitions, which means you have to be able to figure out, okay, how do I move things across all these hundreds of chains in a manner that is very efficient for the user, is fast for the user, and allows the user to do whatever they want to do in the most efficient way as possible, without sort of like introducing any additional or heavy security or trust assumptions here. You don't want a case where users have to give you their keys to sort of like execute and orchestrate transactions, because in some ways it violates the ethos of crypto. You want to do this in a manner that's very, very compatible with the existing system. So this sort of leads us to a new form of middleware that we've been talking about for the last, I guess, 6 months at World Labs, which is like the chain abstraction providers. You think of chain abstraction providers as middleware providers that sort of take on this responsibility of orchestrating states, figuring out these state transitions, and providing data to applications in a manner that is useful. In the ideal world, users won't have to do any of the stuff I just outlined. Wallets and apps won't have to do it either. It will just be the job of this sort of like middleware infrastructure provider. That's all it is. And that's a chain abstraction provider. And in true crypto fashion, there wouldn't be a crypto talk without shameless self-promotion. But us at Orb Labs have built a chain abstraction provider called Orbi. Orbi makes it possible for any wallet or app to offer chain abstraction. And that's little as 5 lines of code. It works with any account system. And with this, you can basically sort of like just take your wallet and interact with any application seamlessly without having to care about any of the underlying details of where your assets sit or what's going on the underlying chains. Because all of that gets handled by this neutral third party that takes over all the responsibility. And it's not just a matter of talk, actually. We built out the system, and in this video, you can basically see the chain abstraction provider at work. There's very little text in the video, so it might be a good idea to explain it before we sort of like play it. But in this video, you see us. We forked Rainbow, made 5 changes in the code base. Took only a few hours. And with that, we're basically going to interact with Uniswap on base using assets tested across 4 or 5 different chains. The system just figures out this stuff and then sort of executes the transaction seamlessly. You as an end user do nothing different, just sort of like plug and play, and things just happen. And enjoy the next 40-something seconds. Have to replay that again, sorry, but I think that does the job. Yeah, there's no splicing point here, but I think I just messed with the presentation. Thanks.
Thank you.
We have time. So we have time. Any questions?
So, as a chain abstraction dude, I was wondering if you could go back to that video and you mute the sound and then actually like explain
Just talking with one another?
which chain. Yeah.
Sounds good. Okay, look at that. Let me step down here. I can't see too well. Thanks. All right. So yeah, over here we're showing Uniswap on base. That's the reason why we stopped here to show you the base logo. So this is Uniswap on base. You can try it out yourself and see that's exactly how Uniswap on base works. And we're starting off by showing you the balance of our assets on the Rainbow Fork. So as you can see, there's about $46.70 in USDC total on across 4 different chains, which are highlighted there. Which means collectively on this cluster of accounts, on these 4 accounts, we have enough US dollars to USDC to sort of execute a transaction on. But as you can see in the list, we have like $20 on base, which means we technically don't have enough money to execute this $30 transaction. But when you go to Uniswap, remember Uniswap will stop you from doing this because Uniswap will realize that you don't have $30 to execute a transaction, so it'll just tell you. So that's what blurred out, it'll tell you the funds. But in this case, you don't see that because the chain abstraction provider is providing Uniswap with correct data, telling Uniswap you have $46 across all the chains that you have. And so Uniswap is like, okay, if you have that amount of money, that's good for us. You can go ahead and execute the transaction. And so we enter in the $30. And with that, we're trying to buy wrap fees. It's going to end up giving us, I guess, 0.0098 wrap fees. We can go to our wallet and look at how much wrap fees we have. As you can see, we have 0 wrap fees on base. So now we're going to execute transaction. Confirm the swap. Everything happens normally as it would on Uniswap. Over here, what we're doing is we made a page in the Rainbow wallet to simply show you what transactions are happening and what's happening across different accounts, just to make sure you're aware of what's going on. But this is basically a stylistic thing. Anyone who's going to your wallet can find this page any way you want. And over here you can see where we're moving USDC from in the other accounts to basically execute this transaction. For example, we're moving $5.97 from one chain, $3 from another chain, and all of that's going to base to execute this $30 transaction. And you click approve as you would any other transaction, things just happen. I think it's how now $30 is gone. $30 up to 46 is gone. We now have $16.70 close 46. And we have nothing on base because we just used all of that base USDC to execute our transaction. But let's go to our wrap fees. Our wrap fees balance is gone now. Oh, you also notice that our minimum balance changed because we started from USDC from there to execute our transaction. Now we go to base on, there we have our $29.90 worth of wrap fees, 0.0098 wrap fees on base. Which is basically the token that was sort of off the transaction.
And it only took one transaction that you had to sign?
Yep.
You had to sign only one transaction?
For you, the user, yes. The chain abstraction provider is handling everything else. Yeah. So, as far as you're concerned, with in the world where, let's say a year from now, every wallet has a chain abstraction provider embedded in there. And every app is sort of like doing the right thing of just getting information about your account from the human wallets. Bridging as a concept is gone. Just go to any app and just sort of execute it. Any transaction you want. The idea of how you get gas tokens is gone. You can just sort of like execute transactions with any sort of gas that you have in your wallet. If you want, probably even fiat. In fact, there's a world where folks may not even hold crypto assets for transactions anymore. They just execute transactions directly in their bank account. And they have it on any wallet because the chain abstraction provider in tandem with whatever system you use for the accounts is going to sort of like make that possible.
So how much of this chain abstraction component is custodial in nature? If you're only signing one transaction to execute that.
So none of this is custodial, and only the user signs the transaction. I didn't think the wallet signs the transaction. So in this case, how this chain abstraction provider works is it tells your wallet all the things that need to happen across all the different chains. Your wallet shows that to you, and if you're comfortable with it, you approve it, and the wallet will just batch sign them all, have things execute. So everything is still non-custodial. You basically hold everything. The chain abstraction provider has no control over your accounts. These transactions that are directly presented to the wallet can be verified through third-party security protocols and software like Blockade. You can check every transaction and make sure you're okay before you execute. So in many ways, yeah, the crypto experience doesn't change, and security is basically in line with whatever you currently have.
So is it like a gap for this transaction just like if you're swapping money, you really spend it in this case, transaction is not taking you to see how it like all the it's in the open.
So I haven't used 1 inch's gasless transactions, so I can't speak to that. But in terms of how gasless transactions work in this case, the system doesn't, the chain provider, generally speaking, at least a good one, doesn't think from the perspective of, hey, here is the amount of assets you need to execute a transaction. It just thinks of each transaction as having certain precondition states that need to be met. Those precondition states can be certain amounts of assets, can be certain amounts of gas, can be any sort of thing at a particular time. And it figures out, okay, what those precondition states are, and tries to satisfy all of them before sending a transaction. Rather than tries to give you transactions that, if executed, will satisfy all of them before sending a transaction. And that, if it involves gas, it just happens naturally in the process. Yeah, but it doesn't necessarily require you to sort of like grant any special permissions to, I guess, the direct application.
I think the demo was like from the wallet side, right? So you also mentioned that you could integrate this from the app side. Could you quickly explain that?
Yeah. So your two ways out absolutely change our providers. The first one is something that already happens on most apps, just don't pay attention to it, which is the apps currently need a way to get information about the transaction being set up. So unless you're using the EIP for auxiliary funds, which I don't remember the number for it, because there are a lot of numbers. But if you're not using that EIP, you're just sort of like using, you're just getting information already from our standpoint. If you just switch to now requesting most information about the user account from the user wallet, your app is now compatible with any chain abstraction provider. Any wallet that comes with a chain abstraction provider is technically usable on your sort of like front end, and they can just sort of do things smoothly. But let's assume that you're working with this assumption that user wallets don't have chain abstraction providers, and they're just sort of like using crypto the Stone Age way, right? You just sort of like execute transactions one by one. Then in that world, we have something called a Borby kit, which is a kit that allows you to sort of extend most of the functionality to the best of our ability to the application as well. So in this case, you'd be able to offer gas abstraction, chain abstraction as well, and a handful of other sort of like features without users having to use wallets to have chain abstraction providers. The experience is slightly worse than the chain abstraction provider experience, but it still gets you very close to it. Yeah. And I'm up on time, so yeah. Happy to take any other question somewhere in the room, or you guys can sort of just reach out to the World Labs team on Twitter, and happy to talk to them. Thank you.